And here we are back. We just talked in part 1 about whether our parabola has a max or a minimum, and we base it all on the value a, ax squared plus bx plus c. So if a is positive, greater than 0, our parabola looks like this, and it has a minimum. If a is negative, the parabola opens downward, and the parabola has a maximum. Example 4, identifying the vertex. We're going to identify the vertex of each parabola and then give the minimum or maximum value of the function. So in part A, we identify the vertex as to where the graph changes direction. So you can see from negative infinity, we are decreasing. At the point where we come to the vertex, the graph changes and becomes increasing and heading off towards positive infinity. The vertex is that point where our graph changes. So the vertex is here, and we identify it, negative 1, 2, 3. Our x value is negative 3. Our y value is positive 2. So negative 3, 2 would be our vertex. Here we can see a parabola opening downward. So if we saw the function, we would understand that a was negative. We locate the parabola as to where the graph changes from going positive to then going negative. We are at 2, 5. The vertex sits at the point 2, 5. You guys try the check it out problems. Identify if it has a minimum or a maximum and give the coordinates. Pause your recording, come back, and check your solutions. So in part A, we locate the vertex, negative 2, 5, and this is a maximum. The graph is opening downward. In part B, we locate the vertex at 3, negative 1. This is a minimum because the graph is opening upward. We can also talk about the domain and range of our parabolic functions. It says, unless a specific domain is given, you may assume that the domain of a quadratic function is all real numbers. You can find the range by looking at the graph. So we can see, in this case, for the graph of x squared minus 4x plus 5, the range, or the y values, begin at positive 1. Remember, the range are the values, the y values that satisfy the function. We can see that the graph does not go anywhere below the value y equals 1. It has a minimum at y equals 1. So we say that our range is all values of y greater than or equal to 1. To find the domain and range of this function, we're going to take into account a couple things. The graph opens downward. So we identify the maximum point. We are at negative 5, negative 3. So the maximum y value is negative 3. That means our range is less than or equal to negative 3. To find the domain and range, we know that the domain is all real numbers. This graph will come down and go out forever in both directions, left and right. It's going to open up increasingly. So we say that the x values are all real numbers and y is less than or equal to negative 3. Please try the check it out problem 5a. Find the domain and range of this function. Pause your recording, and come back and check your solution. Step 1, it says the graph opens upward, so identify the minimum. We identify the minimum to be at negative 4. So our range values will be all y values greater than or equal to negative 4. Find the domain and range. Would you? Thank you. The domain, again, for all parabolas opening up or down is all real numbers. The range, however, is y greater than or equal to negative 4. Please try 5b and pause the recording and come right back and get your solution. So first of all, we try to figure out if we have a max or a min. We can see that the graph maxes out at the y value 3. So our range will be all y values less than or equal to 3, our maximum is 2, 3, the value 3 indicating the y value. Step 2 is to find the domain and range. Remember, the domain, or x values, will be all real numbers, and the range, y, will be less than or equal to 3. In your notes, I'd like you to answer these two questions as a somewhat of a quiz. Number 1, is y equal to negative x minus 1 quadratic? Explain your reasoning. And number 2, in your notes, y equals 1.5 x squared. They want you to graph that. So create your table of values and graph on the graph paper. Seniors are so rude. So please notice that on PowerSchool is your assignment, and it's also right here. I want you to do 22 through 69. Wow, let's make that 23 through 69 odd. After you get done with that, if you finish in class, Mrs. Rourke will have a sheet for you for some extra credit on some more factoring of quadratics and polynomials, because that will play a huge part in Chapter 8. We start to use our factoring skills in order to find the zeros of our parabolas. So, Lesson 8.1, 23 through 69 odd, and those are due tomorrow.